No, it's fine. This is the data type that you're going to have to basically learn. Because this is what we're selecting over here when we select the fence, and bits, and that's what they're called. So bool means it's a what? It's a 1-bit number, right? Don't say that. You can either be a what or a 0 or 1. A byte is an 8-bit number. This should be up there on the Blackboard side. If it's not, they'll let me know. A word we already know about. Then we have an unsigned small integer. So that's what S means. Unsigned small integer, which would be 8 bits, which would give us unsigned. It's a 16-bit. This gives us. By the way, this is the way we specify base. This is not going to make much difference right now. But the way we specify the base is we put the base out to the left, and then we put a hashtag, and then we can put the numbers up there. So this is the way, by default, the PLC displays everything in decimal, which is okay when you get into timers and calendars and stuff like that, it's fine. But when we get into and bitwise ORs and stuff like that, and setting up what we call masks, then you're going to have to understand this right here. So this is the way we tell the PLC that we're using a different base besides decimal. So if I want to use binary, then I'd put a what? A 2, a hashtag. And then I enter the binary number. If I want to do octal, I say 8 hashtag and then enter the octal number. If I want to do hexadecimal, which is the easiest to use, by the way, then I put 16 hashtag and then I type the hexadecimal number. So this is the way we actually specify the base. We're using double integers, signed integers. These right here. So this is an 8-bit number. So that means we get ranges from 128 minus 128 to 127. We have integers, signed integers. So int is a signed integer. This is 16 bits. So we get minus numbers 32,768 to 32,767. And this is the guy right here. Ars Logic 500 called it a long word. But this bit right here, this is a 32-bit signed number, which means we can represent signed numbers from 2,447,833,648 to the same number and a 7. And why do we have one less positive number than we got negative? 0 eats up one of your positive slots. So this is what it stands for. And if you talk it, you listen to videos, they say that's a dent. That's an int. That's a cent, and that's what they're going to call it if you look at videos when they talk about these numbers. So by default, it's going to choose what you did. Then we have real numbers. Real numbers are signed numbers. So this is a 32-bit number, but it uses exponents. So it says, why do we get more right here? Why do we get more right here? Well, these are exponents. So you have so many of them, so many of the bits. So bit 32 is the signed bit. Then you have the whole number, and then you have the exponent that you raise that whole number up to. So that's why we can get such big numbers with real numbers. That we don't normally use this. We're going to have to use real numbers if we have fractions. So anytime you have a fraction in a math, you're going to have to do real numbers. And it won't shift. It's just like your calculator. I think it's around 20 bits. 20 bits, it'll do the number, but if you get above that, it'll shift in the engineering notation or scientific. So timers. Use non-retentive and retentive on-delay timer functions to create PLC ladder diagrams. Use off-delay functions. So we're starting right where we was at in PLC 1, where we ended up at. We're going to use a move instruction, interlocking timers, and cascade timers. Then we'll look at another thing too. So, in motor control, so we have three types of timers, of course. We have mechanical or relay timers. We have digital or solid state timers. These are relay logic. And in the PLC, we have programs, right? You understand that? So these are some typical relay logic timers. This would be we call it a dash spot timer because it actually has two diaphragms in there, and you control the flow of how fast it moves through the fluid. So I mean, the fluid from one side to the other. It's usually got an adjustment right here where you set the time. So it's one of those things where you have, if you want 5 seconds, you got to get a stopwatch out and do adjust that screw until you get 5 seconds. So it's not like our PLC timer where we can do that. Then we have the electronic timers. We have some of these where normally you can usually set the time on with a knob, but it's still not exactly accurate. And then we have, this is also and then we have programmable timers where you can make them off delay, you can make them on delay. I don't know if y'all played around with one of those in motor controls or not. I know you will in the sensor class. So categories, we have on delay timers, off delay timers. Everybody okay there? These are relay logic timers. So on relay logic, the coil does not define the timer. The coil is just a coil. What defines what type of timer it is what contacts we use inside the relay logic. So we're looking at which way the arrow points. If the arrow points towards the contact, it's an on delay timer. Right? If it points away from it, it's an off delay timer. So this would be a normally open, on delay, a normally closed, on delay, and your on delay timers are just options. So it'd be normally open, time closed. You understand that? So it would be open until the time was out, and then it would do what? Close. So you'll see that a lot. So normally open, time closed. This would be normally closed, times open. And on your off delay timers, they're the same. So this would be normally open, timed open. This would be normally open, timed closed. So these switch automatically, and then they change states after the time is out. So this would be relay logic. So we just use a coil symbol, and then we give it a name, and then of course we assign it. And I normally you don't see 1 and 2 out there. The book does that too. We assign the contacts to the time. Are we okay? Relay logic for an off delay timer. And then we have timer instructions. So in relay logic, we draw coils, and then the coils will be what actually causes the timer to change and move. And then we use those symbols to indicate for the contacts to indicate whether it's an on delay timer or off delay timer. Okay. Are we okay? So these are the timers. What do you notice is missing right off the bat? T4, T4 something. So what we do right off the bat on these is we assign, this is going to be a base tag. This is not going to be a alias tag. This is going to be a base tag. So basically a base tag is a name that we give to a device that doesn't need an IO port. So we would assign it a base tag. Same way, we would click on the symbol, right click, we'd come up here, and we'd right click right here, right there, and it's going to say new tag. And you're going to, if you choose new tag, the type is going to be timer. If you set it up inside the tag chart, over there where I was changing mine from bin to bool, did y'all see what I was doing? You would come up here and you'd give it a timer. I don't know if I think I closed mine out. I should have left mine open. So I'm going to open it up while it comes back, and then, so we'll open up wiring check 2, and then while it's opening it up, I'll come back to my PowerPoint. Okay, so on delay timing. These are single input timers, so we use them exactly the same way. When the run goes true, these should move to the output instruction side. When whatever the logic we do, as soon as this input over here goes true, then this enable simulated coil is going to go true. And then this right here is going to go true when the timer is done, right? Everybody okay on that? Just like before. The only difference is we would say T4:0. Here we're going to give the timer a name. When this goes false, what does the timer do? It resets to 0, right? Just like ours did. What's missing? We're missing the time base. These are in milliseconds. So you're going to have to know your engineering notation, right? So if you want 10 seconds, you would put 10,000 in there. So what you're going to do is you're going to take your number and shift it over 3 times, right? You understand? If you wanted a half a second, though, you put 500, right? You understand that? Everybody understands? So you should be able to go down to 1 millisecond on it. What's the biggest number I can put in there? Well, it's a DINT. It's a signed number. The biggest possible time I could put would be what? 2,147,000, 127. So that's the biggest you have. What you needed more time with that? Well, you would cascade the timers, right? Just like we talked to you in there. Or you could use time of day. We'll show you that too. So these come true. So this one starts timing when the run goes true. This starts timing when the run goes false. This is on delay. It'll start timing when the run goes true. But when it goes false, when these go false, what happens? The accumulator resets to 0. So the accumulator keeps the time, the current time, the timer's in there. So that's those registers, those files those inputs are the same as it was on the other. What changed is we've lost our time base, so we don't have to, multiply it by anything. We use a name instead of a what? Instead of a data file, right? And our preset, we don't have to multiply it by a time base, it's in milliseconds. Milliseconds, yeah, but if once you start programming this thing and you get used to shifting it 3 ways, 10 seconds is 10,000. 5 seconds would be 5,000, right? And then after you play around with it a little while, it becomes, it will become basically second nature to you, right? So what we would do is over in my main program, my main routine, or what I'm going to do is I'm going to come down here and I'm going to add a rung. Okay. And then we'd put some type of control for our timer. And notice the groups are laid out across the top. So here's our palette. So here's favorites. So this is where you can put anything in there you want to, and I'll show you how to do that later on. So right now, these are the defaults, which are the same defaults that we had in RSLogic 500. So we have new rung, we have down drop, we have examine if closed, examine if open, output enable, output unlatch, and output latch. So my timers are here. Here's my time on, right? See that? What am I going to do now? Well, I'm going to have to give it a name. So I'm going to come up here and write. I'm going to right click on this and I'm going to say what? New tag. Now what's nice about this is that if you go this route, it automatically chooses the data type for you. If you go over there here, then you're going to have to choose that. It's a base tag because it's not referencing an input-output port, right? And then we give it a name. By the way, this thing does not allow spaces. So notice when you hit the space bar, it automatically puts an underscore in there for you. Okay, so that's all there is. I'll come up here and say create. And then my timer's got a name. Preset, we can put the operating in there immediately. So if I wanted 10 seconds, I would have to put what? 10,000. Everybody okay? Any problem? Okay. Now, how do we address these bits over here? So I'm gonna come up here and add another line. And I'm gonna put a contact over here. So I'm gonna go back to favorites and slide this, oh, dang it. I'm gonna go back to favorites and slide this guy down here. I did. Okay. So I want to address the done bit. Well, I'll start in timer, right? And it'll start popping it up. Timer _1. Now there's no such thing as slashes here. Everything is dots. So I put a dot, and then now automatically it gives me options. So it says, okay, are you going to address the preset? Well, I'm going to address the what? I'm going to address the done. And that's all we have to do. So there's no slashes. Everything's dots. So we separate with dots, right? In RS Logic 500, if you use a dot, you were talking about 16 bits. Over here, we're using names. So so there's my done bit. If I wanted to address the enable bit, I'd use the what? I'd use .en. And if I wanted to address the timer timing, which is just like RS Logic 500, they don't show you that bit that's available to you. But I would come over here and I'd use timer timing, right? So I'd come over here and do what? Instead of using that, I would use, T2. It lets me do it. Yeah, there we go. Timer timing. So that's the big difference. So it's a lot cleaner. We don't have, so what's nice is that it's using the memory for one time. I don't know how much it takes. By default, it's dense. By default, it's a 32-bit signed number. But if you get up in the billions on your time, you got, so I don't think we'll have any problems, but we can't go above, the range that's available to us. Same way for off delay timers, same way for retentive on delay timers. What's the difference between a retentive on delay timer? It has to be what? Reset. So there's our reset. If I go over to timers, there's our reset instruction right there. So it's exactly the same. You pull it down and you would give it the same name. So if I was going to use, a retentive timer, see, ain't that neat? You see what I did? I just did what? I went up in the title bar and just gave it that 3 digits, that 3-letter acronym. So if you learn those little, I guess they're more mnemonics than acronyms. We can change it over. And then I would have to come down here. And then I would have to put something that reset the timer. And then over here, I would come over here into my timers. I pull down reset. And what do we want to reset? We want to reset timer 1. So all I have to do is give it the what? Give it the same name. No, I didn't give it the same name. You say, what's it? That's all we do. So as soon as we do that, that's all there is to it. So and now we're dealing strictly with names. So this is why in PLC 1 I required y'all to use symbols to get ready for what? For this. And what's nice is here we don't even, all we deal mostly with tags. We call them tags. They don't call them symbols. But this would be what we call a base tag. So what's the difference between an alias tag and a base tag? Yeah, you're right. So this is that IN6 is an alias. This is the base tag right here. So it's when we tie a name to a base tag, which is our inputs and outputs, those are called alias tags. So that's timers, guys. Very easy, especially from what we learned from RS Logic 500. You can come directly into this. The only thing you need to know to go to 5,000 is what? We don't have to worry about time base, right? Our preset is in what? Milliseconds, right? and we don't do T4, we just assign it a name. And how did I do that? One way we can do it on the fly is do what? Right click and then say, by the way, I don't know if y'all can't see my very top one. It says what? Edit tag. So if I screwed up, I could come back up here and rename that tag, but it would still be the, so y'all see that? That's really neat too. I know, you're like me, I never make mistakes, right? Yeah, I'm very watching all that. Okay, so timers. Any questions on that? Very similar. In fact, it's easier. To me, it's what?
It looks way more simple than RS
Well, the problem is, RS Logic was okay as long as you used a multiplier of 1. But when you use that time base of like if you wanted to get those fractional seconds, if you wanted to use that, you had to do it in here. It's just milliseconds, guys, and that's something that's something that should be second nature to a technician, right? You understand? We teach that way back in Intro to Engineering. Normally we would intro to engineering, we wouldn't have 10,000 milliseconds because that's not legal engineer notation, but that's the way it works. So pretty easy. So counters. What about counters?
This doesn't have that thing you got to do the number, right?
We'll see. We'll program one and actually see it. No C5s, right. It's just, we just call it, and you don't have to call it counter one, you can call it, these tags can be pretty big, so you can actually, and what you need to do is use a tag that basically defines what that timer or that counter does, right? And then when you come back and look at your program, you don't have to figure out, if you call it timer 1, it's just what? Timer 1, but if it's like if it's timing this, then it would make a lot more sense. But every time tags we can't put spaces in there, but it already takes care of that for you. What did it do? It automatically put that underscore in there. In fact, I've seen sometimes they just hit the underscore. So here's our so the timer has got to be a what? Now I'm going to check on this. So we got three addressing modes. So whatever the instruction works on is referred to as an operand. The instruction itself is the operational code. It came up from machine language programming. So if it says immediate, what that means is you enter the number in, just like I did. So according to this guy, this came right out of the book, by the way. It says, according to this, we cannot use any other addressing mode or the preset except immediate address. But I don't think that's right. I'll have to go back and read. So what is immediate addressing? It means that's the number. So that 10,000, since I entered that number in that preset register, that was immediate. That's immediate addressing. So immediate means you actually put the operand in the instruction itself. Direct addressing or tag addressing means you get the operand from somewhere else. So what we're doing is we assign it a tag, and the tag is kept in the tag table, right? You understand that? I'm almost sure that I'll check this out and see if we can use tag addressing on this. So maximum preset is what? 2,147,483. 2,147,483,647 milliseconds. That's a lot of milliseconds, isn't it? And what if you needed more time than that? You'd let the done bit on this one do what? Start the next one. That's exactly. Here's how we address these things. So we put the tag. These are Boolean. These are single bits. We put the tag .en if I want to get the enable bit. I put the tag name .pp if I want to get the timing bit. I put the tag name .dn if I want to get the done bit. The preset is a dent, right? But I would use what? I would just tag name .preset, or I'd put the tag name accumulator if I wanted to access these, or not registered, these files. Or memory locations. I guess that would be good. Are we okay here? Yes? I don't know, I got that in there twice. Oh, no it is. So timer structure, this is a dent. And then the accumulator, of course, is going to be a dent. You understand that term, right? So what's dent? Yeah. 32 bits, right? Timer address is going to be a timer underscore tag preset. This is the way we address the preset register. The accumulator, this is the way we address the accumulator. And then, of course, the bit. Everybody okay there? Yes, no? So you don't have to worry about when do I use a slash, when do I use a dot, right? You understand everything is a what? Is a dot. Well, no, it's not the alias, it's the base tag. None of these are pointing to an IO address. What's that?
So timer tag is going to be that long base tag. Where it's local data,
No. Sorry. So when I put that tag in, that is a base tag.
Okay.
This is an alias. So an alias points us to an IO port. Everything else is going to be a base tag. Everything. Right? You understand that? So timer 1 is a base tag. It's the base. We don't point this to anything else, right? Does that make sense? Good question. And that's something that's very important that we get into, that we understand. Go ahead. Yeah, a counter's going to use base tag. So notice when I chose timer, I didn't change base tag down there. So when I come over here and if I'm going to put a counter, so the only timer we have to reset is the what? Is the retentive time. All your counters you have to reset, just like on R3500. I need to finish my program so I can download. Okay, reset. So we'll get rid of it. So I'm gonna come up here and I'm gonna change this to count up. And we'll add it. So see the tag? So we'll type it in. Base. I'm changing this over to a counter. But it's got all the information that I used in there before. So I'm going to come over here and change my data type over to a counter. By the way, this is the list of all the data types we have. So we're not going to get into all of these. And if you know what data type it, so timers are going to be a timer data type. So you can just start typing it in. You don't have to go through that big long list. Okay. So now we got up counter. You'll see how I changed that instruction. It's pretty neat, right? Preset. What are we going to hold in the preset? No, this is a counter. What our goal? What we're counting to? Right. This is the counter. So what we're counting to? We got 2 bits available to us. We have the CU, that's the counter enabled. So as soon as this goes true, every time it goes true, then the counter, so this will pulse with the count, right? And then we have a counter done that tells us when it's through. What happens if we keep counting after it's done? So just keep counting, right? So what do we have to do to clear out the accumulator? Reset it. Or clear it, by the way. I'm going to show you another instruction. So we have an up counter, we have a down counter. By the way, this is the document. So it's up there. It's up there. And if you want information, I'm here to help you. But what I want you to try to do is look it up in that document, because when you get out there on your own, I'm not going to be there, right? You understand? So if you can come up here and understand this, then this is going to be a step up, because this guy. So this is on the website, by the way. So it's called the RS Logic 5000 General Instruction Manual. It's a PDF. You can download this for free if you just type that in there. It's a PDF file. That commercial with that guy's, all the older people. See that one? It gives us a list over here, so I'm going to go down here to counters. Now here. This shows us, I'm going to come up here and blow this up quite a bit. By the way, it gives you all the function block diagrams too. This is ladder, so we have an on delay timer, we have an off delay timer, we have a retentive timer, count up, count down, and there's our reset. So if you wanted to read what these instructions do, right, you understand that, then I could come up, and they're all linked. So I can come up here to my upload, and it'll take you directly to that section only. So this is up counter. This would be, so this is not available in what? Yeah, so you would have to come up and figure out the code for that. And it's not available in structured text. It is available in ladder. It tells us that our counter is going to be a tag. It's going to be a base tag. It tells us our preset is going to be a DINT. It's a 32-bit signed number, right? It says immediate address. It says I can counter name, what? Dot preset. And our accumulator, we can come up here. It says immediate address. And this is going to be the number. That's going to be true. And then accumulator. Are we okay there? Any questions on that? It says this is all the that's available to us. So counter name dot .cu, that would be the count. That would anytime the counter is enabled. Counter name dot .dn, that would be our done deal. Counter name dot .ob, that would be our overflow. What do we mean by overflow? It means we've exceeded that 1 billion number. As soon as you go, if you try to make your counter go past that much, and I can't imagine anybody that would do that, it would give you, this would go true. And of course, if that went true, then probably what you would do what? Enable another counter, right? And let it start counting from there. So that's the only way you cascade the time. But here you would start the other counter if it had an overflow. That makes sense? And then you'd.
So if recognized.
Yeah. Yeah, so you'd say, as soon as the overflow went bad, you'd stop this counter, and then you'd start another counter. And then you'd have an instruction where you just added both of them together, right? Of course, you'd have to use a real number on that, because you already over signed number. This is a underflow, so this would be for subtraction. So if we exceed the 1 billion, you know, with one more digit, if we exceed that, I need to learn that number too. Then this would be underflow. So this would be for up counters, this would be for down counters. Then the preset and the accumulator. Everybody okay there? This is right out of the document. This is in my PowerPoint. And sometimes it'll actually give you a little that shows you the flow chart, which I don't very seldom use. And then they usually give you an example. So you'll see a bunch of these where I've cut and pasted them right out of here and put them in the chart. This is 2 off delay timers. Everybody okay here? This is in the text. By the way, almost everything that we're going over, we could read it in the textbook. We would just ignore what? The T4 file, right? You understand. But the way it reacts and what the preset does and what the accumulator does, you know, those are the same. And we would ignore the what? The time base. Reset. Everybody okay on the retentive timer? Questions? This is just retentive timer. The retentive timers have to be what? Reset. And what you do is you just give it the same tag of the timer you want to reset, right? Everybody okay there? Move instructions. This is probably the most powerful instruction because we got available to us. Copies the source into the destination. Source can be an operand or an address of an operand. The destination, the address where you want to place the operand. These are the numbers that's available to you. By the way, whatever your source is, your destination, it'll automatically choose the same number system for your destination, right? This can be immediate, or it can be a tag. This down here, the destination has to be a tag. Everybody understand that? Yes or no? We okay? So that's the way I should have shown that you that too. So I'm gonna come over here on this, and I want to make this a memory. I want to make this a memory core. I don't want it like our B3s. Remember the B3s? Those are internal relays. How would I do that for that guy right there? I'm gonna right click on it, new tag, give it a name, make it a base tag, and then hit create. So now that's a memory group. So all we do is we don't assign it an alias, right? We just assign it a base tag. So every coil and every input, well, it'd be hard for an input, but I could come over here. I could come over here now, and I could assign it to what? It'd probably be better if I put it down another coil. So I'll come right there now, and I'll type in memory. And that's all we have to do. So now, this contact is assigned to that memory. That makes sense? Yes or no? So if we want a memory, if we want a memory coil that doesn't have to use an output, and that's what gets a lot of PLC programmers. They think when I put one of these out there, it's got to control an output for some reason, right? You understand that? For some reason, they think they got to have an output, but no. In motor controls, you learn about control relays. Control relays means their contacts are never in the power section. They don't leave the control circuit. If they don't leave the control circuit, then they don't need to use an output. Because you've only got so many outputs on your PLC. So what we do is we give it a memory core, right? So this is in memory, so we're not going to use a watt tag here. We're not going to use an alias tag, we're going to use a base tag. So base tags are what we assign to something that don't use an output. So this is a memory core right here. So you don't have to worry about B3s anymore. Or B10s. You don't have to worry about, if you run out of this, you don't have to worry about adding more data files. So we don't have to, we're not, in this one, we're not, the application is not defining the memory, how the memory is used. You're defining how that when you write your programs, right? You understand that? So like I was saying on RS Logic 500, you get 256 timers. You lose the memory of 256 timers if you don't use any timers. So if your program has no timers on it, and you got that T4 over there, you've just lost the memory. You've lost 3 words 2 times 256. So that would be 6 times 256. That's how many bytes of memory you use. Here, the memory is assigned as you use it. So where's it being put at? I don't know. It's not being put in a data file anymore. It's managed by the application, right? You understand that? So we don't have to worry about the data file. All I got to do is understand the different bases that I deal with. Normally we don't deal with those until we get into some instructions, like when we start stripping off stuff and things like that. Well, there's my first memory. There's my first memory core right there. So we just do what? We assign it a tag, and we leave it as, we don't say alias, we just leave it as a what? As a base tag. Well, what's the difference between a base tag and an alias tag? Yeah, alias tag is tied to one of your inputs and outputs. So that's a memory core right there. That's all that is. Well, no, automatically. Notice that's a very good. No, automatically. So that I should have looked at that. Let me show you why. So I'm gonna edit this. That's a really good point. I'm gonna edit this. And if you do a memory coil, just because I use the coil symbol, it automatically assigns it to a what? 1 bit. Yeah, 1 bit. But that's something you need to check, especially if you change the instruction. Because if you change it, if you edit it, a lot of times it'll keep all the information that it automatically chose before. The problem is, if I come over here, and most programmers, if they know all the stuff about their programs, they'll go ahead and assign the tags automatically. And what the advantage of that is once you assign the tags, then you're doing what? You're dealing with names instead of numbers. Well, see, the problem is if I come down here and make up a tag, let's just say input 10. Notice by default over here it assigns it to a DIN, which is not good. But what I've done is I've just assigned 32 bits to one input. So what we'd have to do is just come over here and start typing in bool and see what it is. So that's over there. It tries over on new tag. It tries to pick a type of numbering system you use. Here the default is a DIN, right? You understand? You have to change it over, and then you'd come over here. If I left this alone, then this right here would be a base tag. So this is where I would assign. It right here. By the way, all the tags, if you use this, all the tags that you've already assigned pops up first, and then you'd have to come down here and find it. So then everything is basically the same. Make sense? So this is a good way to do it, but there's a little more that you have to know about it. So notice up here, it didn't assign it a what? It didn't assign it a label. So that means, but it did choose what for me? It shows me a single bit data type. But you need to do that because if it chooses that dent, then it's going to rip off 16 addresses, and it's not going to do you any good. We'll show you later on what's good about that. So I've got a lot of errors in my code. By the way, you can save errors. What I like about this on RSlogic 500, even when you cleaned your errors up, it started off with errors, right? And even though you cleaned them up, it did what? It stayed over there, and you had to check it. This one, when you finally get everything set up right, so when you get everything set up right, it don't lack something. There we go. Well, when you get everything set up right, it does what? It's not red anymore. So as long as it's red like that means there's something wrong with the water. There's something wrong with that run. So on RSlogic 500, every time you did something, you had to go up there and get the check. And if the error stayed out there, you need to get it. What type of counters do we have? Oh, move instructions. So what does the move instruction allow us to do? It doesn't move, it's copied. So this is what they call it, by the way, in all these programming languages, they call it a move instruction. But it's not technically a move instruction, it's when we copy something into another location. So we can literally take it from one memory location and put it into another, or we can come up here and we can, so here's my counter. So there's something wrong with this. Oh, I can't. There's no such thing as a counter. My tag's wrong. By the way, if we want to do this, we can just delete it. And then allow us to do what? Rename it, right? And what am I missing? Let's see, this would be, I'll just make up one. And the biggest thing people do is they'll double click on it and they'll start doing what? Typing stuff. Yeah. And then it'll stay red and if you got the tags already set up, what I like about this, now you can assign an input to the same switch, right? You understand that? That would be like a double pole, double throw type switch. But it shows you what you've already used, right? But I could come up here and I could come back and I can assign it there. So I can assign it to the same switch. It's just that when it goes through up here, it also do what? Down there. But it grays out if you by the way, notice it automatically gave it the tag.
Did it do that for output?
What's that?
Did it do that for output? Did it do that?
Yes and no. We can do, when can we duplicate output instructions? So output address. An output enable, you can and it won't give you an error. What happened? We demonstrated that in the last class. Some of y'all didn't take it last time. What happened? It ignored the first one because of the way it scanned. So if this said the output was true, and this down here said the output was false, then the output would be false because of the way it scans, right on the thing. So the way it scans and updates the output. So that's the output that guided update. So the problem with that, if you duplicate output enables, then it won't give you an error. And why they don't do that? So when we first started doing PLCs was so slow, the processors were so slow, it would literally miss into it. So what we would do is we'd duplicate this rung. We would duplicate it. The rungs would be exactly the same. No difference. The rung would be exactly the same. And we'd put it multiple times down in the program. And that way it wouldn't miss the input because it had a what? It had multiple chances to get it. So I guess for that reason, that's why they don't give us errors. Even though, now output latch, and unlatch, those we use those in pairs, right? And they get the same name. So the latch and unlatch get the same name. So that's the only time you should duplicate addresses. Give them the same address or the same symbol. So that's a good question. Because if I do it down here, and the guy that teaches the class, he did that, of course I did it too, where he did that and he wanted to show you that no matter what this one is, this one down here, since it scanned the last, it gets priority over the top. But it won't give you one. It won't give you an error. So don't duplicate output enable, which is this guy right here. So that's output energized, I'm sorry. But when we do the latch, for every latch, you have to have a what? Unlatch. And it'll get the same name. What time is it? Oh, we're fixing to get out of here. So let's look at so we'll pick up and look at a little more detail on the move instruction. So this is, by the way, these are the programs I actually made, so I need to go back and correct that. So let me bring this up and let y'all see what I did. So I've got this program out there. So according to the book, the actual general instructions, it says that the preset can only be immediate address. I guess technically it is though, because it is the operand. It's just that I'm putting the operand in there two different ways, right? So I guess technically it is. I mean, it's just that here we're using a move instruction. Y'all see the address? So I'm taking 10,000, and then I'm gonna take if this rung is true, I'm gonna put it into timer 1's preset, right? And if this rung is true, I'm going to put this 1500 in the timer 1 preset. But it's still, so that's right, it is immediate because that is the number. So, if this was a tag, we'd be pointing this to an address. So that's right, that would be immediate address. So the move instruction, what can we do with the move instruction? We can put anything we want to into any place. So I'm going to show y'all something new when we come back to class. It says that move instruction though. What's the number of systems that we can use? Oops, where's the man? So here's move. And here's the move instruction. And it says that we can use any of these number systems. So I can use a small integer, an integer which is a 16-bit signed number, or I could use a double integer which is a 32-bit signed number, or I could use a real number which is a real big number. whatever you put in the source, it's going to automatically select for the destination. It says the source, we can either be immediate or it can be tag addressing. And then, by the way, we can use a string. Do y'all know what a string is? This is something you need to learn. What's a string? It's a word. So we can literally move a word, a word like help. We can literally put it in anywhere we want to do, which is pretty neat. So that's what a string character is. So tell me everything we know about up counters. And we'll show y'all next class. We'll put I got my program on, but we'll look at the down counter and see if it works the same way as that weird thing on what? RS500. So remember on RS500 you had to load the preset with a negative number. There was a way around that too, by the way. I should have showed you how to do that. I might bring it up and show you this move instruction. What we can do with the move instruction is instead of loading the preset, we set the preset to 0, and then we use the move instruction to put a number in the accumulator. No, here, but on the RS Logic 500. So on the RS Logic 500, if I wanted to see a down counter, I could use the move instruction and set the preset to 0 and put like 15 in my accumulator. And then it would go 15, 14, so it will count backwards, but you still have to go 1 past 0. So you have to go to -1 before the done bit. So yeah, so that's what most people would do because it gets confused and load it with a minus number, right? So what most people would do is they would put a positive number in the what? In the accumulator and let it count down from that. But I'll show y'all that too. I don't think I showed you that. Okay, so y'all got any questions?
Are we using the thumb drive?
Yes. By the way, there's some tape. Let's find some tape so you can put your name on it.
What already got my name on the short?
Huh?
I got my name on the short already.
If you got your name on it, that's fine. Then I'll find the box where we can put it. I'll be there and save that.
Any topic quizzes anywhere? Because I remember like
the topic quizzes are not there. Because why? Because I'm having to redo the whole. Redo the whole class for RS Logic 5000. So all the topic quizzes are set up for RS Logic 500. So if I have time, we might work on that. That's one of my projects if I can get around to it. Oh, you don't know. So if I get everybody's thumb drive, I think that everybody was here tonight. I should have brought a Sharpie over here too. Some of y'all could mark on that. Oh. No, it's fine. So some of y'all can actually write on it. We don't have a box. So how did it work out?
We got temporary time. And then
The rig never showed up.
we put that's what we're gonna have. Look at your thing. Trainer and Mark, because he said they were.
The drawer's supposed to have. Which one?
We put a front.
Um,
So, if I remember correctly, and unregulated power supply, it goes from 90,000 power supply.
You have the transformer, you have the rectifier, and that's it.
But I was trying to do.
The more you keep adding, so start off with transformer, rectifiers, unregulated. Transformers, regulated, filters.